In this video, we're just going to go through a circles review, so a bunch of vocab and things we've already learned. Okay, so the radius, excuse me, goes from the center of the circle to the outside and is half the distance of your diameter. I'm going to go through these pretty quickly, so go ahead and pause the video every single time another one of these pops up so that you can fill in the blanks. Diameter goes all the way across and goes through the center of your circle. Minor arc is labeled with 2 letters and it is less than a semicircle. Okay, and this should say 180. Major arc is 3 letters. Remember, minor is the only one with 2, and is bigger than semicircle, which means semicircle is also 3 letters and is half your circle, so 180 degrees. Circumference is the distance around, so it's 2 pi r, or d times pi, and remember it's labeled with just units. Area is labeled with units squared. Okay, and the way that we remember this is going to be r squared. Okay, and this is made up of the square units inside your circle. Okay, so if we draw some, radius, remember, goes from the center of the circle to the outside. So if we want to say r and a, we would say RA. We always like to do it with the center to the outside. Okay, if I do a diameter, it has to go through the center. So I could say B and A. So diameter goes all the way across through the center is half of your radius. We're going to add another couple letters in here. Okay, minor arc, remember, is less than your semicircle and is labeled with 2 letters and is the outside of my circle. So I could say CB, I could say BA. And remember, we put arcs on the top of them. Okay, major arc is bigger than half your circle. So I could say B, CD, or I could say, I have 2 A's. Let's make this a T. I could say BTD. Okay, semicircle is half your circle, so I could say BCT, or I could say BAT, and remember those have arcs on the top of them. Okay, so we're going to name some minor arcs. So I could say CD, I could say CE, 2 letters. I could say EF. Okay, major, I could say CEB or CDB. Remember, you can skip letters. Semicircle is half my circle, so I could say CEF. Or I could say DEB. Remember, you're never going to use that center letter because arcs to talk about the outside of your circles. Okay, find the circumference. So circumference, remember, is 2 pi r, and the area, which is pi r squared. So in this, my radius is going to be half that diameter, so 8. So I just plop that 8 in here. So 2 times 8 gets me 16 pi, and then we just label it centimeters. I plop my 8 in here. 8 squared is 64, so 64 pi centimeters squared because we're doing area. Okay, my radius is 10 because that's my center to my outside. So C equals 2 pi times the radius, so 20 pi centimeters. A equals pi times radius squared, so 100 pi centimeters squared. Okay, remember central angles, if it comes from the center, it is going to match its arc measurement. So if this is 30, the arc measurement's 30. This is something that you're going to think is really easy right now, and then we're going to forget it once I show you all the other rules. So if it comes from the center, it's the same. Think center, same. Okay, so in this, I'm going to go ahead and find all the missing stuff in here first. So if I look, this represents 180. So if I do 180 minus 114, I should get what that angle is going to be, which is 66. And it's going to represent that arc. So this arc is 114. That little box means 90. So if I work that, 180 minus that 90 gets me this to be 90. Now I can go through and find all my missing parts. So UV is 90 degrees. VST, so VST, I add them and get 156. VSU, VSU. So I could either add all those or 360 degrees all the way around my circle minus 90 will get me 270. Okay, ST, it's a minor arc, so I need to make sure I go the short way, so 66. And then my last one is UTS, 180, when I add that 114 and that 66. Okay, I look to see what these represent. They represent a semicircle, which is 180. So I take 2A plus 24 plus A equals the big angle, which is 180. So I add my A's, subtract 24, divide by 3. Okay, it looks like I have all three. So all the way around is going to be 360. So 20A minus 30 plus 2A plus 4. I need to make sure I include all of the arcs since I'm setting it equal to 360. So 20A plus 2A plus 10A is 32A. Negative 30 plus 4 plus 2 is negative 24. Add that 24, divide by 32, and I get my A to be 12. Okay, this little boxy means 90. I've got all the way around my circle, so I make sure I include all the way around my circle when I set it equal to its big, which is 360. I add my x's, my numbers, I'm going to subtract, $280, not $290, divide by 10, get 28. Okay, so now if I want a piece of the outside, so this tells me I want outside, this tells me I want a piece of it. So the arc length, a length of the outside. So we use circumference because we're talking about the outside. Okay, so I'm doing A to B, so arc measure divided by 360. Since we're talking about the outside, it's 2 pi times the radius. You type everything in but pi because I want pi in my answer. So 80 divided by 360 times 2 times 5. Okay, so if you need the decimal because it's converting it to a fraction, just press that double arrow above your enter sign, and I get 2.2 pi, and then since we're doing arc length, length of the outside, or circumference in a sense, we label it centimeters. Okay, so our next one we're doing ACB. So to find the degrees, I do 360 minus 80, and I get 280 divided by 360 times 2 pi r. So 280 divided by 360 times 2 pi r. Okay, again, if you need to get the decimal, press that double arrow above your enter sign if it does not give it to you, and I got 7.8 pi centimeters. Okay, our last thing is go ahead and try this one on your own, so pause the video. So I'm going to do 60 divided by 360 times 2 pi r. And I get 3 pi units. Okay, so that is arc length. Now we're doing area of a sector. So instead of 2 pi r at the end, now I want a slice of the inside. So I'm going to do arc measure divided by 360 times pi r squared. That means I want a piece of my inside. So 30 divided by 360 times pi r squared. So 30 divided by 360 times pi r squared. Get the fraction, or the decimal, so 2.1 pi inches, and since we're doing area, squared. Okay, the last one I want you to do of sector ABC. So I do 360 divided by, or subtracting 30, so I'm really doing 330 divided by 360 times pi r squared. So 330 divided by 360, and I get 22.9 pi inches squared.